More than 100 years ago, the Titanic slipped beneath the icy waves of the Atlantic. It was a legendary tragedy. But what if the patterns of who lived and who died weren't random? What if there was a code hidden in the chaos? Well, today, we're going to see if a machine can crack it.
I know, it sounds like something straight out of science fiction, doesn't it? But that's the real question we're tackling. Could an algorithm look at your data, your age, your gender, what class ticket you held, and actually predict whether or not you would have made it off that ship?
So where do we even start? Well, our guide on this adventure is a pretty simple Python script. We're going to walk through its logic step by step to see exactly how a computer can learn lessons from one of history's most famous disasters. All right, let's think of this like a detective story. The case file is called the Titanic Survival Challenge. The central mystery? Who lived and who died. And our detective, well, it's not a person at all, it's a machine learning model. Every great detective story starts with gathering the evidence. And for us, that evidence is data. So the very first thing the script does is load up the passenger manifests. These are the digital files that hold all the clues we're going to need. Now here's where it gets really clever. The evidence is split into two files. First, you've got train.csv. Think of this as our historical case file. It has all the passenger info, but it also has the answer key. It tells us who actually survived. Then you have test.csv. It's got the same kind of passenger info, but the survived column is totally blank. These are the new unsolved cases our digital detective needs to crack. You know, raw evidence is almost always a mess. It's jumbled, it's incomplete. You can't just hand it over to the detective. First, you got to clean it up, get it organized, and make it presentable. In the data world, we call this super important step pre-processing. And here's why that matters so much. Our model, our digital detective, is brilliant for sure, but it's also very literal. It has no idea what text like male or female means, and it just gets stuck if it sees a blank space. So we have to tidy everything up first. So the script breaks this big cleanup job into two really simple tasks. First, fill in the blanks where we have missing info. And second, translate all the text, the words, into a numerical language that the machine can actually work with. And check this out. It's a perfect example of that first task. So for some passengers, their age wasn't recorded. It's just empty. So what does the script do? It doesn't just guess. It looks at all the ages it does have, finds the middle value, the median, which was 28, and uses that to fill in the gaps. It's a really smart and logical way to fix an incomplete clue. Okay, and here's that second key task in action: translation. The machine doesn't get words. So the script sets up a super simple code. The word female becomes the number 1, and male becomes the number 0. Just like that, gender is now a mathematical clue our detective can use in its investigation. So, with all the evidence cleaned up and translated, our detective knows what to look for. The script has told it to focus on these 6 clues as the most important ones. Things like passenger class, sex, age, and even how much they paid for their ticket. These are the variables it's going to hunt through for patterns. All right, the evidence is prepped. The top clues are identified. Now, it is time to train our detective. Seriously, this is where the real magic of machine learning kicks in. The model is about to learn from history. So what do we even mean by training? Well, the machine basically just pores over that train.csv file, our historical file with all the answers, again and again and again. It's looking for hidden connections. It's figuring out things like, it looks like when passenger class was 1 and their sex was 1 or female, the survival outcome was really, really high. It is literally teaching itself the patterns of survival from the raw data. Okay, the training is done. Our detective has studied the past and has learned the patterns. Now it's the moment of truth, the final verdict. The model gets that test CSV file, the unsolved cases, and is asked to predict the fate of every single one of those passengers. And there it is, success. This simple message from the script tells us that everything worked. Our digital detective finished its analysis. The predictions are in. You could say the case is closed, at least according to the machine. And this right here is the final report, a brand new file called submission.csv. It's a simple list, passenger ID on the left and the model's prediction on the right. A 1 means the model thinks they survived, a 0 means it thinks they didn't. So for passenger 893, a female in 3rd class, the model predicted she survived. But for passenger 892, a male in 3rd class, it did not. Let's just stop and think about that for a second. Without anyone ever telling this machine about the Women and Children First Protocol, without it knowing what a lifeboat is, it figured it out. Just from the data. It analyzed the numbers and independently discovered the unwritten rules of survival on that horrible night. That is pretty incredible. And really, that's the big idea that leaves us with. If a few lines of code can find such profound meaning in the chaos of the Titanic, just imagine what other powerful, unseen patterns are hiding in plain sight in all the data that surrounds us in our own lives. What codes are we just waiting to crack?